I thought it would be fun if we just kind of do like a little bit of a poll. Like how many people are doing front-end engineering development today? Everybody. Awesome. All right, how many people are doing, let's start with like React. Okay, Vue. Yeah. And then Angular. Any Angular folks in the audience? Wow, a lot of you guys are doing React and Angular. Yeah? Did I see a lot of like double up on that? That's good. And then when I say Angular, so like, you know, Angular had this really bad marketing snafu where there's like this old thing called AngularJS. When I'm talking Angular, I mean like 2+. So we're talking like 5, 6 now today, soon to be 7 here in a couple weeks actually. Well, great. Thank you so much for coming out to my talk. We're going to be talking about progressive web apps with Angular. We're going to dive into what PWAs are, talk a little bit about them, and then we'll also get into the Angular implementation of using PWAs today. So, my name is Brian Love. You can follow me on Twitter. I tweet mostly about Angular and web technologies and things all around the Google platform. I'm the CTO for a local consulting company called BrieBug based out of Lakewood. And I'm also a Google developer expert. I actually just got like last week, so I'm super excited about that. Yeah! So actually I'm not even on the website yet. I have to actually put in a pull request and add myself to the website, so that's cool. So we're getting there. And I'm also a co-organizer for the Rocky Mountain Angular meetup. I'm from upstate New York. The contrast is a little off because we're going to try to show some code. But just so you know, like this is the city, and then the rest is called upstate. And this is mostly like cows and like small communities and lots of hills and green space. So don't think tall buildings and like, oh, you're from New York, I love New York, because you've probably never been to where I live in New York. So, but that's all right. I enjoy skiing in the outdoors. This is my beautiful wife and me skiing up at A Basin, and then a picture from the Kitzbühel Alps in Austria. But that's enough about me. Let's talk about progressive web apps. So what exactly is a progressive web app? So if you go on the MDN web docs, you're going to get this nice, beautiful sentence that says that progressive web apps use modern web APIs along with traditional progressive enhancement strategy to create cross-platform applications. So we'll kind of break that down over the next 45 minutes or so. Google basically gives you 3 criteria for a progressive web app. They say that PWAs need to be reliable, fast, and engaging. And what do we mean by reliable? Reliable basically means when I'm using your application, it should be reliable whether I'm on a slow 3G connection or if I'm offline, I don't have any connection. It should be fast, right? So we talk about things, when we talk about fast, what we really mean is the time to interactivity, or TTI, right? So we want a minimal time to interactivity when I'm on a slow 3G connection. And it wants to be, your PWA should be engaging, right? So a progressive web app should be like any other app that you're using on your desktop or your mobile device, right? So we want that same UX experience that you would expect from an app. This is a quote from one of the guys, Alex, I believe his name is, out of Google, that actually kind of came up with the idea of PWAs. And progressive web apps are kind of still newish today, but I think they actually wrote this blog article in 2014 with this concept of like, hey, what if web apps were just like native apps? And what would that kind of look like? Let's escape them out of the tab progressively, but let's not build hybrid apps, right? So when we're talking about progressive web apps, we're not talking about a download, right? We're not talking about something that's deployed to the App Store or to Google Play, right? This is not an app, like you're not using like Electron or some other wrapper like that to build your application, right? We're talking about progressive, meaning it progressively becomes an app. It goes from an app that you run in the browser to an app that you're running on your device, your phone, or your desktop. So PWAs are likely apps that you're already using today, right? So that's kind of the buy-in, is think about like the App Store. Like the discoverability of the App Store is great because you can go on, you can see like it's got curated content, you kind of see what are some cool apps, or maybe somebody recommends something to you, right? So you kind of browse this store and then you make a purchasing decision, whether it's free or not free, right? But you basically say, oh, I'm going to try this out. The idea of a PWA, it doesn't have to be, but the general idea is like, this is something that you're already using a lot of. Let's say you subscribe to the New York Times and you use it, you're on their website all the time. But what if you want a richer experience, a better experience? So you go ahead and you install the app, and now you get exactly, or maybe not exactly, but you get that same experience kind of that you had on the mobile version, but now it's right, launchable right from your desktop, from your home screen. You can switch to it, and it's Chromeless, right? It's broken out. So when I say Chromeless, no back and forward buttons, and it has its own UI experience, just like you would expect from a native app. So let's talk a little bit about cross-platform real quick. Thankfully, I'm really happy that we got that E on the end. That just happened like a couple months ago. So in the browser, progressive web apps have been supported for a while now, right? Firefox, Chrome, and Safari have supported it, and then Edge just came online this last year. On mobile devices, we've had PWAs in Android for a long time now, and Safari also just, in iOS, just adopted it this year as well. So I'm going to show you a demo of a PWA literally running in like an iOS simulator, and we can install the app right onto the home screen and see what it looks like. And then just this week, just this week, Chrome 70 dropped, and Chrome 70 supports progressive web apps on Windows 10 in a desktop. So you can literally have an app in Chrome on Windows 10 and install the app right onto your desktop. It'll go onto the start menu and then into the desktop as well. I think they're targeting Chrome 72, which will probably be about 6 months or so until we actually get that same functionality in Mac OS and Linux. So it's coming. Yeah, so I've got a quick demo for you. Let's see if this works with the play. Okay, cool. Hopefully you can see that. So right now I'm in Safari. I'm on app.starbucks.com, right? So this is just a normal experience that you would get in Safari in the browser. Go ahead and open up your drawer, and you can't really read it, but there's this Add to Home button, and it's going to pop up a screen where you can change the name of the app, and now you can see Starbucks is literally an application running on my mobile device. Now notice that you get kind of a black bar up top where the panel is with the time. And it's a full, sorry, the resolution here is not great, but it's a full working app, right? And it's the exact same experience. Actually, if you were to, I don't know if you have the Starbucks app on your phone, if you've ever used it, but this should look really familiar, right, to what you're used to. This is a progressive web app. This is running in the context of a browser. It's offline capable, works on slow 3G connections, and it's all built with web technologies, right? And you can deploy this to all those different contexts that we just saw. That's pretty cool, right? I mean, no more like trying to build hybrid apps and deploy both the Google Play and iOS, dealing with getting through approval processes and store and everything, all that like headache, right? I don't know if you've ever done like React Native or any mobile development, but it's a pain in the butt, right? This is easy. So this is hopefully the future of progressive web apps on all devices. Now I will say, and we'll get into it a little bit, Safari supports progressive web apps and service workers, but there's still a lot more that they need to do to actually support more and more functionality. So they're getting there, but so they've got limited support right now. Let's see how we get to the next. Cool. So how do we accomplish this? Well, there's 4 things that we're going to dive through today. We're going to look at the app shell. We're going to talk about service workers. We're going to talk about what's called a web manifest, and we're going to talk a little bit about progressive. So that's our agenda for the next couple of minutes. So let's talk about an app shell. Has anybody ever heard of an app shell before? Kind of that concept? A couple of people in the back? Okay. So the idea of an app shell is basically, let's go ahead and, again, we want to minimize that time to interactivity, right? So instead of shipping my entire app and all the content that comes with my app, what I'm going to do is I'm actually just going to ship the app shell, right? So the shell of your app might be like, in this case, like a top nav bar, and maybe you have some links or something like this. Maybe there's a hamburger menu with a fly-out menu or something like that. And so what I'm going to do is I'm going to create this app shell, and it's going to be minimal, right? We're going to have no blocking content. We're going to render it really quickly. And we want to have that app shell ideally within like a half a second to a second. So really, really fast, right? And so we're going to deliver that app shell to the user first. And then after we give them the app shell, we're then going to load in our content like lazily, if you will, or dynamically afterwards, right? So that's kind of the first idea around building progressive web apps. And if you're already using something like Angular, that concept actually isn't really that foreign. So let's dive into service workers. Service workers is a new specification, or somewhat new specification for web APIs. And service workers enable us to do things like offline, right? We can cache files in the browser. And I'm not talking about like local storage cache or something that like you're doing apps today, right, in the browser. And when the user goes to your web page the first time, it's going to cache that, and it's going to be in there for some time until like the browser decides, okay, I'm going to flush this out of the cache. And there's a whole algorithm how they determine that, right? But I'm not talking about that type of cache. I'm talking about a type of cache that you actually control. You can put things in the cache, take things out of the cache. There's an entire cache API built into browsers now, and we'll look at some of the specs on that. And that allows us to actually do things like serve the app straight out of cache first. What if somebody comes to your website, like rather than just going and making a bunch of network requests, we send them the app shell with just the browser, simple shell around your app, and then everything else just loads right out of the cache, and you deliver your app under a second, right? Or something really, really fast like that. Service workers also enable us to do version management, right? Just like any app in the App Store, right? Like there's new versions of your app, right? And so with service workers, you can manage which version the user is running. You can update them to new versions in the background or force a new version on them immediately if you want to. But the idea around PWAs is like versioning should just be seamless to the user, right? When they launch your app, they just get like, that's the web, right? That's the beauty of the web, is like there is no like download and update and all this kind of hard cycle, right? So same with PWAs, let's use that same concept that we have in the web and let's roll that into apps. Our apps just update automatically, right? There is no like, I have to go to the App Store and download and update and install it and wait for it to install and all that stuff. It just happens. Service workers also enable notifications. So that's part of the engagement side of of web apps, right? Your native apps have things like push notifications or desktop notifications that fly in on the right or whatever it is. And the philosophy here is that PWA should be like apps, right? So we should have notifications. And then we should also have background sync. So if the user's offline and they do a bunch of work, well, hold on a second, when do I know to send that back up to my cloud or my server, right? So here's the idea of basically the service worker actually runs when it's idle. So when the user goes to their home screen, your service worker is still running. It's not a browser, right? So it's actually still running. And in the background, we can go and say, oh, I've got connectivity now. Go ahead and send all that data up to the cloud or sync whatever synchronization needs to happen. I didn't put an asterisk on both of these last two, but let me just say real quickly, the notification API is pretty solid. The push notification API is still in flux. So they built it around the Google Cloud push notification API, and they're going to go to more of a standards approach. So you should see some changes to the push notification API in the next couple of releases of Chrome and other browsers as well. And then background sync 2 is still in the early stages. Something that's still kind of being decided upon, being adopted by the browser community. So let's quickly talk about the life cycle of a service worker. So at first, you don't have a service worker installed. And the service worker is kind of a big piece of this whole idea of progressive web apps. And it's what's running all the time. And we'll talk a little bit more about that. When the user chooses to install the app, whether in iOS you're going to swipe up and do add to home screen, In other contexts, you can actually prompt the user to install the app, or they can click a button on your website and then they'll get a native prompt from the browser to install the app. So that's what's going to happen first, and we can respond to that installation event and do things around that. And then once the application is installed, there's an activation event that is fired as well. Most of the time you don't need to do a lot during the activation phase. You'll do most of the kind of heavy lifting of installing your app shell and caching your resources necessary during installation. But during the activation phase is also where you can do any sort of cleanup as a result of the installation. So it's kind of another event that your application can respond to. You can also respond to the error if during the installation there was some sort of problem or the service worker got terminated unexpectedly, and you can handle that. And then after it's activated, your service worker basically goes into an idle stage. And an idle stage is where the service worker it's running and it's waiting for any fetch. Anytime the user is trying to fetch anything, doing a fetch request, or it receives a message via a notification or a push notification. And then finally, there's also a terminated stage. So when your service worker is in idle, the OS can actually choose to terminate it whenever it wants. So always be aware of that, and you can respond to that as well. Okay, we got our contrast up nice and high, so thanks, man. So we can progressively install a service worker. Your users can be using your web app today, and they could be using an older browser like IE11 or something like that. And just because they don't support service workers doesn't mean that we have to break on it, right? So that's what we mean by progressive. So we want to progressively register a service worker if it's available. So we just simply check if service worker is available in the Navigator, and then we can use the Service Worker API to go ahead and register our service worker. When we register our service worker, we're going to point it to a JavaScript file that's going to be executed in a special context. And we'll talk about that a little bit more in a second. And that's going to be a file that you're going to have as part of your application. That'll get downloaded by the browser and then executed. And then next we get into the installation phase. Here's where we're actually going to install our application on the device. So you'll notice that I'm in this context of self. Laser pointer, sorry. This context of self, this is the context that our service worker is executing in. And we can add an event listener to this installation. So we add event listener to install. We give it a callback function where we get that event. And then we can call event.waitUntil. Event.waitUntil basically says, hold on, don't terminate this service worker until this promise resolves. And this cache.open is a promise. We're going to go ahead and open the cache, whatever we want to call it. We can version our cache as well. And then once the cache is open, that also returns a promise. Once that cache is open, we can go ahead and cache all the content that we need. And the content that we're going to cache is going to be that app shell most of the time, right? So that's going to be our application. So in this instance, you might want to cache like the favorite icon, the HTML, which is that app shell, your CSS, and then the JavaScript that runs your app shell.
And this is that sw.js file.
Correct, yes, so we're now in the context of that sw.js file. Yes, thank you, good question. The other thing that we have in the lifecycle hooks is the idea of a fetch, right? So anytime a fetch occurs, we can go ahead and, go ahead and if you want to boost that a little bit for us. Thanks, man. So anytime a fetch occurs, our service worker is kind of like a man in the middle. Now, whoa, I know you're like, whoa, man in the middle? That sounds horrible. This is actually a good thing, right? So your service worker actually sits there in the middle, and we can there's some controls around that. And anytime a fetch occurs, it's going to go to the service worker first, right? Now the service worker has full control, can say, what do I want to do with this fetch? Do I actually want to go out and fetch this resource? Or do I want to get it from the cache first, and then maybe fetch it lazily, and then replace the cache afterwards? And we can get into all kinds of strategies around what we want to do when a fetch occurs. Again, we're going to get the event, and we're going to use respond with. And we want to do a couple of things usually as a result of our fetch. We want to check if this resource exists in the cache. If not, let's go ahead and fetch that resource, then cache it, and return that cache resource. If it's in the cache, and we trust our cache, and you can make all these decisions, you go ahead and you can give that to the user immediately. So imagine somebody launches your app, and they've already got everything cached. Boom, they launch it, that's it. You don't have to go and wait, and there's no loading indicator. You just launch your application, up it comes. Now, you can go ahead in the background and start fetching stuff if you want, and then replace that as needed. So you have kind of full control over what's in the cache and serving directly out of the cache first if you want. So let's go ahead and take a look quickly at that code. For those of you that are kind of want to see some code, I've got some code here for you. So we're basically going to get a request, right? So we're going to see if that cache, if that request is in any of our caches. So there's a method called match, which returns a promise. And then when that resolves, we're going to get that response. And we're going to basically return that if we have it. So if it's in cache, go ahead and return that. If that's undefined or a falsy value, or we're going to go ahead and fetch. We'll use the fetch API to fetch that request. Then when that returns, we'll have that response. We'll go ahead and open up our cache again. We'll go ahead and take that cache object, and in the cache we'll call the put method, and then we'll put our request and response into the cache. And then we return that response after we received it. So there's a couple things to note, and I kind of alluded to this already. Yeah, go ahead, you can drop that. Yeah, I'm out of the code section. I think I might have one more code slide when we get there later, just so you can read some of this other text. Sorry, I didn't realize we were kind of dealing with an older technology here. So a couple things to note. So it's that context, remember when we saw that SW.js file, and we referenced self. That context is called the Serviceworker global scope. The service worker runs in this, it's a JavaScript worker, and it has no access to the DOM, right? So it's a little bit different than any other kind of script that you would be using normally. It also is important to note that in order to use the service worker, you have to be using HTTPS and TLS, right? So you've got to serve it with an HTTPS. That shouldn't be that should surprise us at this point. I will say there's an asterisk here because you can actually serve it from localhost, and then that restriction is not there anymore. So you can do local development as long as it's on localhost. The browser basically says, okay, that's fine, you can use a service worker. And I put this last one in here because I read it in the documentation. I don't know of anybody that does XHR with synchronous requests. Honestly, anybody. But if you are, for whatever reason, you can't do synchronous requests in a service worker. Everything has to use the fetch API. Real quickly, let's also dive into the cache storage. Yeah, if you want to bring maybe the brightness down a little bit for us, thanks. Got this beautiful green color.
Yes, it
looks horrible, doesn't it? It's a little bit better, thank you. So the cache storage is one of the modern web APIs that we're talking about as part of Serviceworker and the Serviceworker implementation. The cache storage is the storage for cache objects that are available to that specific service worker. So obviously there's limitations like, Google.com can't access Apple.com service workers, right? And so there's domain restrictions on that. So you'll have access to the cache objects that are available to you in your service worker. And you'll be able to, they're available via the service worker global scope.caches. So if you remember back on some of the code slides, I'd switch back to it, but it's probably going to be unreadable. But we did things like caches.match. So that caches is available within that scope, kind of like a global variable. We can use the cache storage.open to access a specific cache based on the name. It's just a string that you give it. And then we can also, like you saw, we can use cache storage.match. We can use that match method to determine if a request is in any of the cache objects. And if you look under the hood, you've got multiple cache objects within a cache storage, right? So it's like a one-to-many relationship. When you call cache storage.match, all it's going to do is just do object.keys, iterate over it, and just find the first match in any of the caches. So just so you know, there's a little bit of magic to that. You can write your own if you want to do that yourself. The cache object itself is a storage mechanism for request and response pairs. You can kind of think of it as a map, if you will, of request and response object pairs. And the cache allows us to do a couple of things. We can match on a thing in that specific cache, and whereas cache storage will look in all the caches. Again, that returns a promise that resolves if the request exists in the cache. And then we can put things in the cache, we can delete things out of the cache, we can get a list of all the keys of the cache, these kinds of things. So it's just an object pair storage of requests and responses. I guess I had one more code slide. Sorry, man. The last thing that we're going to kind of look at here in terms of the Serviceworker API is notifications. So here, we've got a button in the element. This is just vanilla JS. We've got a button with an ID of subscribe. We're going to add a click event listener to that with a callback function. And then notice I'm accessing a class called notification. And on that class, we've got a static method called request permission. That request permission will actually prompt the user in the browser. You get like a native OS prompt in the browser to ask for permission. You probably have seen this on some websites that are like asking you if you want notifications. Honestly, I think it's really annoying that people are doing that. Notice my example, I have a button. I really think the user should be triggering to request for notifications. I think it's super annoying that a lot of websites these days are just like, hey, we want to notify you and stuff. And you're like, whoa, I never asked for this. Like, leave me alone, man, back off. So please do try to be kind to your users with this API. I think it's a little interesting that they don't mandate a UI interaction with it, but anyways. Yeah, so request permission is going to be a promise. And then we're going to get back this result string. And that result string has, I think, 3 different strings, values, and one of them is basically granted. So if the user said, yeah, okay, I want notifications, we've been granted, and then we can go ahead and start showing notifications to the user. I think we're good. Okay, so that's kind of service workers in a nutshell. There's a lot that goes more into it. You can certainly check out the documentation and dive into that if you want later. Happy to kind of field some questions on that afterwards. Let's talk about the web manifest file. And it's
Promises, yeah.
The last one.
So the manifest file is a JSON file that we're going to tell the browser about that's going to give the browser the necessary metadata about our application. Some of the possible configurations for this JSON file are the short name, we give it the icons for our application, we give it our start URL. This is going to be basically the entry file into our application. The background color, that background color is going to drive some of the launch screen and that kind of thing in the OS. The display property has a couple of options. You can have a standalone. A standalone is the application is going to run standalone without the context of a browser, so no Chrome around it. There are a few other options for display. You can run it in the context of a Chrome browser if you still want to have like back and forward and reload and these kinds of things. The scope is what limits the service worker to a specific scope in your domain. If your app is served at like /app and you only want the service worker to have access underneath that, you can then limit that based on the scope. And then finally, the theme color will drive things like, in iOS at least, will drive the color of that top bar. So if you want the color to be branded to your brand, maybe a particular shade of blue or whatever it is, you can do that. Here's an example in our index.html file. So this would be our app shell. Notice the link tag here on line 4. We use the link tag with a rel of manifest. So kind of like a style sheet, we use manifest. And then the href points to that manifest JSON file. That's how we tell the browser that we are a PWA, and go ahead and parse this JSON file and make it available to the user to install our application as a progressive web application. In this context, for those of you that are doing Angular, this probably looks a little familiar. This app shell is very basic. We just have the app root, and that is going to be where we would have our entire application live underneath. Great. So we've talked a lot about progressive web apps and service workers and the manifest file, but the title of my talk is PWAs in Angular. So let's start to dive into the Angular side of things. Just a note, when we talk about the progressive web app implementation in Angular, this is going to be for Angular version 5 and greater. So 5 was released last September, I think. So if you're using, as long as you're using Angular 5 or 6, you can use a lot of the modules and a lot of the stuff that Angular ships with to support progressive web apps. And Angular truly loves PWAs. Clearly, Google has a passion for progressive web apps. Google kind of started this idea of progressive web apps and has been kind of leading the community in this term. And Angular is a Google framework, right? So you can imagine that Google is all on board with progressive web apps, and so is Angular. We get a couple of really nice things in Angular when it comes to PWAs. First of all, there's an entire module that is we can import into our application, the Serviceworker module that ships with Angular 5 and Angular 6. Angular loves single-page apps. That's what it's good at. I've seen people try to use Angular to create little widgets on a page. Angular is really not built for that. AngularJS, React, Vue, go that route if you're just looking to make a little widget that you're going to load up, and ship from .NET or Ruby on Rails or whatever on the back end. Angular itself is built around the idea of single-page apps. And single-page apps lead directly into progressive web apps, because that's what they are. It's running in the context of the browser, it's rendered in the browser, and Angular loves single-page apps. Angular also comes with code splitting right out of the box. So when I talk about code splitting, Angular will use Webpack and creates bundles underneath the hood. And we can ship just our main bundle to the user and a vendor's bundle and a polyfill, right? And then from there, we can actually lazily fetch all the other parts of our application when the user wants to actually go into that part of the application. Or if you want, you can actually pre-fetch some of those bundles as well. And what that means is a really quick time to first paint. So we can have Angular go ahead and just ship that app shell, and then we can split that code up, and we can all the other features of our application, we can go ahead and lazy load that, or we can prefetch it, or do whatever strategy we want later. So Angular is really built for doing fast applications, and you get this code splitting and lazy loading right out of the box. I also mentioned prefetching. Like I said, you can go ahead and prefetch those other bundles as necessary. And then Angular also ships with server-side rendering as well. This is a big part, especially when the user first starts to use your application, before they install it and you actually cache all the resources. We can have Node render the Angular application already. So that way we're not doing client-side rendering or CSR, right? So with SSR, we can render the entire Angular application, ship that to the browser, get that time to interactivity really, really quickly, and then we'll swap out that kind of stubbed out version with a live version of the Angular application right underneath the user. It's kind of seamless to the user, and they get a really fast, immediate display of their application. They can start interacting with it immediately. So there's a couple of steps to get started. You can start with a brand new Angular application. If you're not using Angular, there's a very powerful command line interface, or CLI, that Angular ships with. You can use the ng add. Angular 5 added the add command. ng add will add any additional module and run a series of what are called schematics on your application to wire everything up for you. When you run ng add at Angular/PWA, this will go ahead and add to your package JSON the necessary dependencies. It will modify your application to import the necessary modules. It'll add the configuration files as necessary. There are some configuration files that Angular uses itself for the progressive web application in terms of configuring your resources that are fetched and how they're fetched and the strategies around how they're fetched. So it'll add all of that for you and get everything kind of wired up. So you can literally, if you want to, if you can go home after this presentation, you can ng new, a new application, simply run ng add Angular PWA, and then you can serve out that, and instantly you've got a progressive web app up and running. We need to do a production build, obviously, for an Angular application. In Angular, we'll use the ng build command to give it the -- prod flag, so that way we have a production build. And then we need to use an HTTP server, not just the built-in Angular server that comes with the CLI. So we use HTTP server. You can just install that real quickly with yarn or npm. And then we're going to load up that local host, and we'll have it serve out from the dist folder. And dist is where we just built our application to. So here's a quick example. You can see I'm in localhost 8080. Down at the bottom, underneath applications, it's a little blurry. You can see that the application was installed. At first, the application is going to be shipped from the server, but now you'll notice underneath one of these columns, which I can't read, it says that basically all the content of my application is coming from a service worker. So it's that easy. You literally just install the app. Once it's installed, you can see that it's running in your browser underneath the application tab. And then once you do that second load, here in a second you'll see it again. If I refresh the browser, now all those files just got shipped out of cache from the service worker. So super easy to get up and running with PWAs in Angular. So you might be wondering, well, what exactly is cached? In Angular, we're going to cache a bunch of assets automatically for you, and then you can kind of configure this and drive this as you see fit. By default, we're going to cache the index.html file, so that is your app shell. We're also going to cache the icons, and then we're going to cache all the JavaScript and CSS files that are in your dist folder. So anything that was generated by the Angular production build. We'll also cache any assets that you ship with your app. Those kind of assets could be things like icons, or maybe you have some particular files or images that you're displaying that you want the user to always have available in the cache. Finally, you can also cache any sort of resource URLs. And we'll talk about some strategies around how you would do that. What I mean by resource URLs, I'm talking about fetching data. So let's say that example of like the New York Times app. Obviously, you can't ship to the user every story that you have available, right? And so you're going to ship an app in that app shell, have a nice experience, maybe a nice landing page available to them. And then when they choose a story, or maybe you load in that list dynamically, we can go ahead and cache that. So let's say I'm sitting on the tarmac, I'm browsing through New York Times, I'm reading a couple articles, I go into airplane mode, and now when I launch into those stories, I have them cached because I've already fetched them and I've put them in my cache. There's some strategies around how you can do that if you want. There's a couple of different installation modes when you configure an Angular progressive web application. You're doing a great job. Great job. We have two installation modes that are available to configure in Angular. The prefetch allows us to ensure that the resources are available when we're offline. This is what I would think is the recommended approach. Basically, we want to go ahead and when the user installs our application, we want to prefetch all of those files that I just talked about, that index.html file, all of our CSS and JS files. Let's go ahead and grab all of those things and it's part of the installation process, and let's get that put into the cache. So that way they're available and ready to go. You can also do it lazily. Basically, the resources are only going to be cached when they're requested. So if you have your app split into a bunch of different bundles, when you do it lazily, it's going to actually try to do a network request and get those bundles just in time when the user requests them. Or again, we can prefetch the entire application and store it in the cache. Angular also deals really well with versioning. I actually was really surprised at how seamless this was, which is awesome. They've done a really good job with it. So when we serve our app from the cache, we install the application, and the user goes ahead and they launch the application. By default, we're just going to grab all that app from the cache and serve it up immediately. So that way the user gets immediate feedback, the app is running, it feels like a native app. Then what we're going to do is we're going to wait a couple of seconds, there's like a timeout, and we're going to go ahead and try to do a network request and see, oh, is there an updated version? And if you're not familiar with Angular, every time you do a new ng build, there's a new SHA, there's a new string that's generated for all of your files, right? And it's unique. And that's basically how Angular determines whether it's a new version or not. It's going to compare that hash against the previous one. And if the hash is, if you've got a new version available, it's going to say, oh, okay, great. Let me go ahead and download that app in the background. So the user's using your app, they have no idea. It'll start downloading the app and it'll pull it and put it into cache. You will be notified programmatically, and then you can choose to immediately reload the entire app with that new version, or by default, the next time the user launches your application, it'll swap it out and run the new version. And that's it. It's completely transparent to your user. Very easy to do. Angular just ships with that right out of the box. There's also 2 different app modes that I want you guys to know about for requests that are already cached. We have prefetch and lazy, just like we saw before, but these are for updating files, so not the installation. This is post-installation when I'm updating files. For requests that are already cached, I can prefetch, so I can download and cache that request immediately as soon as that happens, or I can do it lazily as well and wait until the user requests it, and then cache that new updated version. The SW update is a singleton class that exists in Angular. It's registered in the dependency injector, so you can provide it into any of your classes via the constructor. And we can use the SW update to inject this instance into our class, and then we can determine, we can programmatically react to things that are happening in our progressive web application. The available method notifies us when we have a new update is available to be installed. Activated will be fired when that new version is activated. We could, if we wanted to, we could tell the user you've got a new version available, or just installed a new version, or you could do some sort of logic around that. You can also determine if you're actually running in a service worker context, so if it's enabled. We can check for updates manually if we want to, instead of letting that kind of happen automatically for us. And we can activate an update immediately. So when we determine that we have an update, like I said, we can immediately reload the browser, install the update, and reload the browser, so that way they get our update immediately, not the next time the app is loaded. For all of our data requests, so when I think data requests, I'm talking about when we're going out and we're actually fetching content that's out like inside of our app shell, right? The actual content of our app. And we've got some strategies around how we are going to cache that data. We can determine max size. So we can say, hey, when I get to 100 items, go ahead and start purging things out of the cache based on the age. I can also set the maximum age of cache requests, so that way if the data, if it becomes stale, you can determine that max age if you want. There's also a timeout, which is the maximum time that we're going to wait for a request before we fail over to what's already in our cache. And we have strategies around that. So when we do a data request, again, it's kind of a man-in-the-middle approach where the service worker sits in the middle. We can say that we want to take either 2 strategies, performance or freshness. Performance says, go ahead and just use the cache version first. I always want to trust what's in my cache. Freshness, we'll try to fetch the request, we'll try to fetch that data. And then based on the timeout that you set, if it reaches the timeout, you're on a really slow 3G connection, it'll fail over and use what's in the cache. So I've got a couple of pro tips for you before we finish up. Don't cache your service worker. If you ever run into like, whoa, this is really not working, I don't understand why I'm not getting like new versions of my app or something like that, go talk to your DevOps or to your operation team and say, make sure you add this header, cache control max age 0. So that way the browser, and again, this is not the cache that we've been talking about with service workers. I'm talking about like just the cache that we all know that exists today, right? Let's force the browser to never cache that service worker file. Otherwise you're going to run into issues when you actually want to go deploy new versions to your users. The other thing that I want to give you a kind of a pro tip on Angular ships with a really powerful, easy to use module for doing progressive web apps. I will say, as much as I love Angular, the module that they include doesn't maybe do everything that you might need to do with PWAs today. And that hopefully will change in the future. But there's another great project by Google called Workbox. And I don't know if you have not heard about it, but definitely go check it out on your own time. If you're using Vue or React, I would definitely recommend you do this. If you're using Angular and you're running kind of into that wall of what you can do with progressive web apps with the built-in module, check out Workbox. It's a very, very extensive API. They've got lots of libraries, lots of great documentation around PWAs. They've got lots of advanced routing and strategies for data caching and loading. It comes with a CLI as well for you to build out your progressive web app. It works with Webpack, so if you're doing something, if you're bundling your application using Webpack, whether it's Angular or React, the Workbox works well with that. Of course, it's Google, so there's a Google Analytics integration, which makes it really easy to track things when the user's offline, and then in the background sync, go ahead and push that data up to your Google Analytics. And lots of features. So again, if you're getting started with progressive web apps, certainly if you're using Angular, I would suggest you start with the Angular module. If you start hitting walls or you need to do things that are more advanced, take a look at Workbox, a great library that's been built by Google that supports progressive web apps as well. If you haven't heard of Lighthouse, I would also recommend that you check it out. Lighthouse is a Chrome. It's in the Chrome DevTools. It's also a Chrome extension, and it runs on Node as well. Lighthouse can be integrated with your CD/CI pipeline, so you can do things to enforce that you're supporting progressive web apps in that pipeline. They have a web app performance side of Lighthouse. We'll check all kinds of performance around your web application. But they also have a Serviceworker checklist included in there as well. And it'll actually score you on how well you're doing in terms of delivering a really great experience for your users using progressive web app. So check that out. So at this point, maybe you're kind of thinking, oh, this sounds great, Brian. I really like what you're talking about. This is cool. But like, this sounds like pretty new still. And should I really get into this? And I'll tell you what, absolutely. Go out, start exploring progressive web apps if you're not doing it already. Talk to management, talk about what it's going to do, the abilities that you have around it. Start thinking about this as a strategy instead of building these hybrid apps where you're building a web application for a user and then you're building all these native applications for users as well. I really honestly think that progressive web apps are the future, so go and check them out today. A couple of things to look forward to. I've already mentioned this, but Chrome 72 is going to drop with macOS support. That'll be really exciting when that happens, especially if you're using a Mac. Safari and iOS. Safari supports progressive web apps and service workers today, but some of that support is still pretty limited. So we're waiting for Safari and iOS to buy more into progressive web apps. I will say, and I know this is being recorded, but I think Apple's got a couple $2 billion standing in the way between them and the App Store and actually adopting PWAs altogether. So I can kind of understand that hesitation. The idea of progressive web apps is to allow web apps to be just like native apps. And so the App Store actually maybe one day would disappear with progressive web apps. And if you know anything about Apple's financials, they make a lot of money off that App Store. So we'll kind of see what happens there. We also have Streams coming out. Streams is a new API for streaming data into your progressive web apps. Not well supported today, but these standards are being evolved, and we should see future improvement in terms of streams, as well as the background sync API that I already mentioned. Finally, you might be thinking, okay, this is cool. I'm buying what you're selling. How do I get started? I would recommend that you check out the MDN web docs. They've got a great little tutorial that you can go through. I think it's about 4 or 5 different sections. They've got a sample app, and you can browse the GitHub repo. You can see how they built it. Definitely check out that website. You can if you just Google search MDN PWA, I think it's the first result. I found that very helpful when I was getting into progressive web apps. Go ahead and check out the Google Developer Network as well. Lots of great information on progressive web apps coming out of Google. The Angular Docs is a great resource if you're doing Angular. Check out the Serviceworker module. And then finally, there's a pwa.rocks website, which is pretty cool. You can check out some existing PWAs that people have built. It's like a showcase of progressive web apps that are out there and live today. With that, thank you. I do want to thank a couple of really awesome people that have been really instrumental in PWAs over the last couple of years. Maxime is another Google developer expert in Angular. Great guy. I think he lives in Finland. And he speaks a lot about PWAs. If you're interested in learning more, go on YouTube and you can see some of his really great presentations. Jake with the Chrome team does a lot of great information on progressive web apps. Of course, the Chrome and Angular team, the MDM web docs and Google developers, and then certainly the developer Denver organizers for putting this together for us. And that's all I got. Thank you very much. Questions, yeah.
Yeah, I have a question. So it sounds like the developer has a lot of control in terms of the caching of the PWAs.
Yep.
So I actually have two questions, two totally unrelated questions. So the first question is, are there situations when the cache, the memory footprint for the cache would be comparable to a traditional app?
Yeah, that's
on the phone?
That's a really good question. So the question, in case you didn't hear it, is what about how much memory do I have in this cache, right? And how much? So I can control, I can delete, put, add things in, see if things are in the cache. So I get a really good control in this cache. But what if the browser decides to just go ahead and just delete my cache, right? So it's a good question. There's an entire document that you can read by both Firefox and by the Google team that will outline how they control the size of that cache. You'd have to put a lot of stuff in that cache to reach. It starts, the first decision is half of your available memory on the entire system. And then it talks about percentages in terms of how much you're using. At the end of the day, I would say you've got plenty of room. But you get to also control that. So it's also on you as a developer to delete things out of the cache once they become stale, or once you programmatically determine that it's no longer needed, especially when you're doing new versioning. So that's where during the activation lifecycle, you can delete old stuff in the cache that maybe you needed for an old version but not for a new version.
Thank you. My second question is, Ionic has been advertising a lot about that they can do PWAs. Do you know anything about using Ionic for PWAs? Do you recommend it?
That's a great question, and I don't know a lot about Ionic and their PWA support. I've done Ionic development, but it was for iOS and Android. So I'd have to check into that. There's a couple of great guys in the Google developer team. Mike Hardington, I believe is his name, who works for Ionic as one of their developer advocates, and I'd lean on him to kind of see what he has to say on that. I'm sure you could do a Google search and check it out though too. So yeah, good question. Yeah, go ahead, man.
So that Serviceworker, when you swipe up and you put the Starbucks icon on your phone or on your desktop, whatever it may be, is that just a process that's going to be running?
Yes, correct. Yeah, so Serviceworkers, it's a process that's running. That's right. So that this is not just a browser where when the user exits the browser, right, your app is done, right? This is a JavaScript worker that's going to continue running until the operating system determines to kill it.
And it's
right?
not dependent on, if I close my browser where I originally got this PWA from.
Nope.
It's still...
Once you install the Service Worker, it's running. So you can, the user can manually kill apps, right? So the user could kill your app just like any other native app, right? And then the operating system can also determine if it wants to kill an app at any time. So you have to kind of be aware of that. But in general, you're kind of in this idle stage where you can respond, and that's where you would get your push notifications. You'd respond to that push notification and show the user a push notification and these kinds of things. And not just push notifications, any notification. You could have some sort of notification that runs in your app for some sort of, maybe you're checking some sort of resource to see if it's available, and something new is available. Maybe you want to alert the user, hey, somebody made a move in a game, or whatever it is, right? So it doesn't have to just be a push notification from a remote service. Yep.
So on that note, so PWA, JavaScript worker, service worker, it will not run once you close or kill the app. So push notifications, if you killed the app, it's not going to happen. Like a native app, you could have closed, but you're still going to push notifications. It's not running in the background. Right?
So if the PWA is not running, then you're not going to get push notifications. Correct. I think so. That's my understanding. Yeah.
And then for that that offline capability, you mostly want to rely on that for content, not for interactivity with like updating a data store, right? Because you can't count on that service worker to be around when, like, if you were counting on that to update your database, then and it never came back online before they closed it, you'd lose whatever was stored in memory. Is that even possible to use this to kind of support an offline mode?
I'm not sure if I'm following the question. Go ahead, say it again.
So like if I wanted to update my profile in this app,
Yep.
and I wanted to now say, okay, I add my middle name to my profile, but I did it offline because the service worker allowed me to do it.
Right.
But I never came back off online, and my service worker was killed at some point. That data would be lost, and it wouldn't actually update my data.
I'm pretty sure the data would still be, as long as you cache it, the data would still exist in the cache. It's just not, the service worker is not running. Right,
that makes
but just
sense.
because the service worker is terminated doesn't mean that your cache is totally destroyed.
Oh, that's cool.
Yep. Is that?
Yeah, for sure.
Yep. I think that's it for questions. I'm gonna let the other. Actually, we're going into lunch. So, any other questions? Cool.
Yeah, you mentioned Chromas, so that removes the URL bar and bar bottom.
Yep.
Do you know in the manifest?
Correct. In the manifest, there is a where I had full screen. There's a couple of, I think it's not scope, but there's another option in the manifest where you can say kind of what you want that context to be.
Okay.
Yep. And I think there's 4 options that you can choose from. And full screen is basically no Chrome around your app. Yep. Cool. Oh yeah, one more question.
So I work for an advertising agency. My boss is really excited about progressive web apps, and he's pushing us to start looking into it.
Okay.
We don't build apps, though we build websites. Do you
Okay.
see applications for them in websites, or are we even on the right track? Should we not?
I don't know. That's a good question. So the question is around marketing websites and progressive web apps. I don't know. I guess I'd have to think about it. I mean, most of the time when we think of progressive web apps, we're talking about apps that people want to engage in an offline context, and they want to have this experience of an app. When I think of like a marketing website, it's because I'm like looking for like your store hours, or your kind of like your information, or where you're located, or whatever. I could see both sides of it, I guess. You do get the offline mode, and if I'm a heavy user, like let's say like it's a dog sitting website, right? And I use your service like every day. My dog goes to doggy daycare. Maybe I want an offline mode or something, so that way I can always engage with your company. I don't know. That's a good question. That's for you guys to figure out. All right, thank you very much. Appreciate it. Enjoy the rest of your day.